I'm going to be doing Let's Practice Problem 3 from Video B of Topic 14. The problem is asking us to find the mass of methyl bromide given the mass of the two reactants and the chemical equation. So the information we have is a chemical equation which is a mole ratio, and we have to make sure it's balanced first of all in order to use it. So we have 5 hydrogens on this side, 5 on this side, 1 carbon here, 1 carbon here, a bromine and a bromine, so we don't have to do anything. We also have these 2 gram values, which is the amount of methane and the amount of hydrobromic acid. Since, as I said, the equation is giving us a mole ratio, these numbers are not very useful given that they're in grams. So the first thing that we're going to want to do is convert these numbers into moles. So to do that, we're going to divide by the molar weight, which is grams per mole. So if that doesn't make too much sense to you, you can just think about it in terms of units. If we have x grams divided by y grams per mole, these grams will cancel and we'll be left with moles. So that's all that we're doing right now. So we're going to divide 13 grams by the molar weight of methane, which is just the molar weight of carbon, plus 4 of the molar weights of hydrogen, because there's 1 carbon and 4 hydrogens. So it's 13 divided by 12 plus 4 times 1.008, and we're going to get about 0.81 moles. We can do the same with hydrobromic acid and divide 21 grams by 1.008 plus 79.9 grams per mole and get 0.26 moles. And if you're wondering where we got these numbers, the 1.08, the 79.9, it should be on your periodic table, or you can look them up online. That's not something you need to know. So now we know how many moles of each. So our chemical equation has no coefficients in front of these numbers, so we know that all these moles are going to be a 1-to-1 ratio. And that allows us to predict how many moles of product will be made from this amount of reactants. So since we have a 1-to-1 with methane to methyl bromide, we know that 81 moles, 0.81 moles of methane can make 0.81 moles of product. And the same with the hydrobromic acid. These also have a 1-to-1 ratio, and we see that they are not the same number. So 0.81 moles of the methane would be able to make 0.81 moles of the product. It was fully reacted. However, we have less hydrobromic acid than methane, so it's not going to fully react. And we're actually only going to be able to make 0.26 moles of the product. Since there's so much more methane than hydrobromic acid, we can assume that the HBr will be able to fully react, and that we can get these 0.26 moles of product. So since we want our answer in grams, we're going to have to convert back once again, and we're just going to do the reverse of what we did before to find the moles of our reactants. So we're going to do 0.26 moles times the grams per mole. The moles will cancel and we'll have grams. And we find this from, once again, our periodic table, just adding up the molar mass of 1 carbon, 3 hydrogens, and 1 bromine. And we're going to get 0.26 times 12 plus 3 times 1.008 plus 79.9, which is going to give us 24.68 grams. However, one more piece of information we have in the problem is our 78% yield. What this is telling us is that our reaction is not going to go totally smoothly, and we're not going to have as much yield or as much product as we expected. We're only going to have 78% of the expected amount. So right now, 24.68 is our expected amount. If we're only going to have 78% of that, we can just multiply the 24.68 times 78 over 100, or just by 0.78, in order to get 19.25 grams, or if we round down, 19 grams, which is our answer. And that's all.